Hi, welcome to this lesson on 2D and 3D trigonometric problems, part 2. Let's have a look at question 8. We're given two ships at sea, S and T, that can both see a lighthouse, HL, where the top of the lighthouse is H on that shore. The distance from the top of the lighthouse to each ship H, S, and HT is given by 200 meters each. The angle of elevation from S to the lighthouse H is given as angle alpha. HTS, so this larger front-facing triangle in the 3 dimensions, that angle is beta. And then angle SLB, so this angle here, which you can think of the body of water here, like the ocean or the sea here, that angle is theta. We want to show that the distance between the two ships ST is given by 400 times cos of B. So my first intuitive mind here would say, cos is involved. So maybe I could use the cosine rule. But if I do that, I might end up with something a bit complex, okay? Because I would have to pull out this bigger triangle HST here. So I'll show you what I mean, HST. That's going to be 200 meters, 200 meters. So these are equal lengths, so this is an isosceles triangle, and we're given this is beta, so this angle must also be beta. Okay, and then this angle here, by sum of angles in a triangle, must be 180 degrees minus 2 beta. Now if I try to use the cosine rule here, I would do it as follows. ST squared equals HS squared, which is 200 squared, plus HT squared, which is 200 squared, minus 2 times the product, so 2 times 200 times 200, times cos of the angle included, which is 180 degrees minus 2 beta. Okay, so already that's quite complex, and it looks like it's going to be a much larger expression than just this one here. So this hints to me that this might not be the way to go about it. So what other rule can I use? So in this triangle, I could also find the length of ST using the sine rule. I could say ST divided by sine of the angle opposite it, so 180 degrees minus 2 beta, is equal to another side we know, so we could pick either one, 200 divided by the sine of angle beta. So let's see where this takes us. Well, if I cross multiply both sides, I get 200 times sine of 180 minus 2 beta all over sine beta. But sine of 180 minus 2 beta, if I look at my cos diagram, okay, so 2 beta is that acute angle here, then 180 degrees minus 2 beta is in the second quadrant, where sine is positive. So it remains sine, and it's the angle 2 beta. Or we could have just used compound angle formulae and expanded out sine 180 cos 2 beta minus cos 180 sine 2 beta, and you will also see that that simplifies to sine 2 beta. So whether you use the cos diagram for reduction formulae, or whether you use the compound angle formulae, both will give you the same result. Okay, and that's all divided by sine beta. But now sine 2 beta is a special, it's a double angle formulae, so I can rewrite it as 200 times 2 times sine beta cos beta. And that's actually going to be pretty helpful, because now we're dividing by sine beta here, that can divide into that, and I'm left with 200 times 2, which is 400, times cos of beta. And that's exactly what we wanted to show. Okay, so it just goes to show that although first instincts would have told us to use the cosine rule there, because we saw a cos there, we saw that that would have not simplified quite nicely. Okay, perhaps if we did the algebraic expansion, simplified cos of 180 minus 2 beta, taken the square roots, we would have also arrived at that answer. But the algebraic gymnastics there will be far more complex than using the sine rule here. Lastly, we want to show that the area of the sea included in triangle LST is given by 2000 times cos squared alpha times sine alpha. So first of all, from our previous one, we know that this length here is 400 cos beta, so that might be useful. Okay, so let's look at triangle LST. S and T. Now, we know that this result must have a alpha here somewhere, and alpha is only in this triangle here, HLS. And we can assume that from the bottom of the lighthouse towards the ocean there, that's going to be like on some sort of bedrock, that the lighthouse and that the ocean, they meet at a perpendicular angle. Okay, so that is a 90-degree angle triangle. There's an alpha and a 200. So we can actually work out the length of SL. And once we have that, we can also work out the length of LT in this other triangle, which will also be a right angle here. And this will be H, this will be L, and this will be T. Okay. And this angle will also, so this length is 200. This angle will also be alpha. Okay. And how do we know that? Well, looking at these two triangles here, HL is a common side to them. They both have a 90-degree angle. Okay. And they both have a hypotenuse length that is 200. So I could say that these two triangles here are congruent by right angle, hypotenuse, and common side HL. Okay, so that's how I can get that angle to be alpha, and that's really important that we're able to do that. Identify congruency within triangles. Okay, so you can see how much geometry is playing a role here when you do your 2- and 3-dimensional problems in trigonometry. All right, so I just need to find the length of one of them because they're congruent triangles, so SL will equal LT. Okay, so these will be equal lengths here. Once I know that, I can then use the area formula. All right. Okay, so how do I find SL? Well, I know I have an alpha, I know I have a hypotenuse length, and I'm looking for the adjacent length. So I could say that the cos of angle alpha is adjacent SL over hypotenuse 200. So therefore the length SL is 200 times cos alpha. And that's really important, okay? And that's equal to LT as well by the congruency. So this length here is 200 cos alpha, and this length here is 200 cos alpha. So now I can use the area formula. So the area of this triangle LST is a half times the two sides, and then times sine of the angle included. Okay, so a half of 200 is going to give you 100, and then 100 times 200, that's going to give you 2000. Cos alpha times cos alpha is cos squared alpha times sine alpha. Theta. And that's exactly what we wanted to prove, that the area of this triangle LST can be expressed using that trigonometric expression. All right, so that's how we do this type of question. I'll see you in the next one.